Video we are going to talk about storage organization and stack allocation of space in compiler design. This is going to work after the intermediate code generation phase, and in this video we are going to see how the memory is going to be managed during the runtime of the generated target code. And in runtime storage organization we are going to have 5 or 6 blocks mainly, and the memory for the generated code is going to be one of the blocks, and static data which is going to be found during the compilation time will be the next block. And to store the activation record we are going to use a stack data structure that will occupy some of the space, and for dynamic allocation of memory we will be using a heap data structure. And runtime environment, how the space is going to be allocated for the generated code which will be running on a machine. And the data objects, the memory requirement of the data objects that can be determined during compile time is known as it will be allocated statically, and for some other it will be found during the runtime, and for them the allocation will be done during the runtime. And the allocation and deallocation of the data object is managed by runtime support package. It will be loaded along with the generated target code. And the execution of a procedure in some programming language we call it as functions, and the execution of a procedure is known as activation of the procedure. And the procedure activation begins when we call a procedure body, and it will be ended when the procedure ends. And the execution of procedure is known as an activation, as I said earlier. And the lifetime of an activation of a procedure is a sequence of steps between the first and last steps of the execution of the procedure. And if you are calling some other procedure inside the current procedure, it will include the lifetime of the called procedure as well. And if A and B are procedure activations, then their lifetime are either non-overlapping or nested, means both the procedures can be executed separately. And if you are calling the procedure B from a procedure A, then it is known as nested procedure. And in recursive procedures, the new activation can begin before the end of the earlier activation, means you will be calling the same function again from the current function, which means the execution of the newly called procedure should be completed before the outer function completes its execution. And to represent the activation or the flow of the control, we can use a tree data structure. It is known as activation tree. Here each and every node represents an activation of a procedure. Root represents the main activation of the main program, and the node A is a parent of node B if and only if the control flows from A to B, means if A calls a function B, then A can be the parent of B. The node A is left to the node B if and only if the lifetime of A occurs before the lifetime of B, means A completes its execution before the completion of B. And here is an example of a nested structure, and we are entering the main function, and main function calls a function P which calls a function Q, and after the completion of Q it calls a function S, means it calls a procedure S, and it's completes its execution. Then the outer procedure P completes its execution. Then we have one more function call for the procedure S. It completes its execution here. Then the complete program completes its execution. The whole program, means we are coming out of the main function itself. If you want to represent the same with the help of a tree, it will be looking like this. Main is the root of the activation tree. It calls a function P or procedure P, that calls a procedure Q, then it calls a procedure S, then the procedure P completes its execution. Outside P also we have a procedure call for the procedure S, so it will form another child of the main function, main procedure S. So if you look at this, P is at the left of S, which means the lifetime of P will be completed before the lifetime of this procedure called S. An activation record to store a single execution of a procedure, means here we in activation tree we saw the flow of control of each and every procedure calls or activations. If you want to store the information for a single procedure call or single execution of a procedure, we will be using one record called activation record, which will be stored in a continuous block or contiguous block of storage. And the memory allocation, deallocation, everything will be represented in terms of activation record, and it will be having a simple structure like this. The return value, the function, the called function, which the value which will be written from the called function to the calling function will be stored in the first block. Then we will be having the actual parameters, means the input of the procedure, which will be coming from the calling function. And optional controlling will be having the activation record of the calling function. An optional access link, the non-local data, means it will be having the links to the global data area. Saved mission data status will be having the status of the mission before this procedure call. Local data, the area in which the local variables are stored. Temporaries, to store the temporary values that will be found during the execution of the current procedure. This is going to be the general structure of a single activation record. So as I said, activation records are used to store the information of a single execution of a procedure. And creation of an activation record, the memory will be allocated partly by the calling function and partly by the called function. Means some part of the activation record of a procedure is created by the procedure immediately it is entered, and it will be created by the caller of the procedure before the procedure is entered, means by providing the input arguments and all. And the deallocation partly done by the caller as well as the callee. The callee deallocates the part allocated by callee. In the case of storage of temporary variable and local variable, everything will be deallocated by the callee itself, and the caller deallocates the other part which were allocated by the caller procedure. And apart from these two, we will be using a control stack to know the flow of control. And the flow of the control corresponds to a depth first search, which means we will be starting from the root of the activation tree, and it will go to its left child and it will explore based on depth first search. So in depth first search, we will be visiting the left child and then the root and the right child. A stack, which is known as a control stack, will be used to keep track of all live procedures. And just in case if you are having a recursive procedure, first procedure call will be pushed into the stack first, then on top of that we'll be pushing the second function call or procedure call. We'll keep on doing that until all the procedures are entered. And if you, while a procedure is ended, it will be popped out of the stack, which means the activation record is popped when the activation is ended. And we'll be having different scopes for variables as well. You can use the same variable name in different functions, but the scope will be varying. And here is an example of that. Here we are having a variable a within the procedure p. Alright, and but b can be used inside this procedure b, but it is declared outside, so it is going to be a non-local variable. And binding of name, static notion and dynamic counterpart, these are the different terms related to the static allocation and dynamic allocation for the same operations. And static notion will be calling, you will be using the term definition of a procedure. In dynamic, you will be activating the procedure, means it is going to be executed. Declaration of name, binding of the name with the memory allocation, scope of declaration, lifetime of binding. These are the different terms that we use for same set of operations in static and dynamic environment. And calling sequences, the procedure calls are implemented based on calling sequences, means in which order it is going to be called and returned. And the values communicated between caller and callee are generally placed at the beginning of the callee's activation record, which means, as we saw in the activation record format, the first two blocks contain the return value and the arguments. So return value will be going from the called function to the calling function or calling procedure, and the arguments will be coming from the calling function to the called function. And fixed length items like controlling, accessing is not going to change its size. It is going to be of same size regardless of the locations. and items whose size may not be known means the temporary variables and the temporary variables will be placed at the end of the activation record. And here is an example of the responsibility of callee procedure and caller procedure, means called procedure or calling procedure, and the temporary and local data will be placed at the bottom, and links and saved status and parameters and return value will be placed on top of that one. And so since both are procedure, both will be having the similar structure of the activation record, and caller's activation record will be going to have the same format as well as similar to that callee's activation record. And this is how the memory and stack is allocated and managed during the execution of the generated target code. Thank you.